Hi, to start today, I'd like you to try these two questions that go back to looking at a topic from a few lessons ago. Pause the video, try these out. So, the answer to the first one, I think the best thing is to get the coordinates of the vertex. That's another word for current turning point. And the answer is -2, -3. Smallest this can be is -3 when this is 0. And what causes it to be 0? When x is -2. Then remember that we essentially get a parabola. So it will look a bit like this. We'll get a turning point and the line of symmetry will go through that minimum. So that's how we get x equals -2. For the second one, we're given the maximum point and we have to find an equation for the graph. This is basically doing the opposite process to this, so you can get back to completed square form. So the answer does it slightly differently, like it writes the answer slightly differently. So I'm going to show you how I would do it. So it's going to be x -2 squared plus 5, but that would be if it was a minimum. So to make it a maximum, we need to change it into a sad quadratic, and then we're going to need to put a minus there. So the answer went straight to writing it as 5 minus x minus 2 all squared, because that is the same. To be fair, that is then simplified. I have found an equation for a graph, so actually I'd even state that this was absolutely fine, but they've expanded it and left it like that. Just for info, there's actually an infinite number of quadratics that would have this as a maximum point. You can, if I just move this along, you could actually put any positive constant there, where k is greater than 0, and that would also work. Today, we're going to look at modeling with quadratics. So we've looked at the topic of quadratics, but how can we apply it to actual situations? And these are some actual physical examples that, they might not be perfectly modeled by it, but there are elements of truth in it. Let's say that anyway. So you are more than welcome to pause the video and try this out. Otherwise, or just listen in to as much as you want to. So a diver launches herself off a springboard. I'm just going to sort of sketch this out, I think, to get me an idea of it. So somebody on a springboard. And then the height above the pool, t seconds after the launch, can be modeled by this function. So it's going to be a negative quadratic. So it's going to look a bit like this when they've dived in. A, how high is the springboard above the water? Well, this is when t is equal to 0. Right at the start, they're going to be on the springboard. We're kind of treating them, to be honest, as like a single particle, not as a person with height, to be fair. It's not really clear. It says the height of the diver, but if they're going down, obviously they're going to be, different parts of the body are going to be at different heights, but we're kind of treating them as a little, like, tiny block, in fact. So when t is equal to 0, we're actually going to get the kind of this y-intercept going on, and that's just going to be 10. So it's going to be, I'm just going to write implies h equals 10, and it does say it's in meters, so 10 meters. Use the model to find the time at which the diver hits the water. This is actually going to be when h is equal to 0, because we're saying the height above the pool t seconds after the launch. So I got a quadratic, and now I can set it equal to 0. 5t minus 10t squared plus 10 equals 0. For these sorts of modelling questions, actually, often the quadratic won't factorise because it's kind of a real life situation. So I'm going to jump straight in and use the quadratic formula here. It's okay to do that. Just it doesn't look particularly nice. Let's just go for it. So menu, down to equations, polynomial, degree 2. Just make sure we put it in right. So it's going to be minus 10, 5, and 10. And that gives us 1.2807 or minus 0.7807. So we'll reject that one because it's negative time. And we'll round this one. It doesn't say to, but it's good practice to round to 3 significant figures. So 1.28 seconds. We're now asked to rearrange it into completed square form, essentially. That's what that means. So let me first of all write it as h equals minus 10 t squared plus 5t plus 10. And then I'm going to factorize out that minus 10. And this is going to become minus a half. Complete the square on this inside part. T minus a quarter. All squared because I have that half. Sorry, that should have been a t. Apologies. That gives me the plus 5t. Minus a quarter, and then I'm going to need to minus 1/16 in fact when I square that 1/4, and then I'm going to be adding 10. Expand that back out, that's going to give me minus 10 t minus, I might write this as 0.25 now, just because I'm sort of dealing with this kind of real life situation where, you know, we're working to 3 sig figs and so on. You could leave it as a quarter, and then I'm going to be adding 10 over 16 because it's minus 10 times minus 1 over 16. So 10 over 16 plus 10. That's going to give me 85 over 8, or 10.625. I could, just to finish, I'm just going to write this on the left, but write down what the constants are. So I'm going to get A equals, I haven't quite written it as they'd like, if they wanted me to be fair, so I should probably do that. 10.625 minus 10 t minus 0.25 squared. Right, that's better. A equals 10.625. B equals 10. And C equals 0.25. So what's the maximum height? It's going to be 10.625 meters. We just jump up an extra 0.625 meters. It kind of makes sense. It's not going to be massively above our original height for a dive if it's being a realistic model when t equals 0.25 seconds. And that's it. We're done. I've not really got room to put boxes around them. Give it a go. We have modeled a situation using a quadratic. All the skills from before have come into play. Nice one. Okay, if you're happy with that, then try this one yourselves. So I'm going to go through it. Interpret the meaning of the constant term 12.25 in the model. Right, let's just read it. We've got somebody is on a tower and they're throwing a spear. And then it also has a negative quadratics. It's going to look like it's going to come down like that. So 12.25 is basically going to be what the value of h is when t is 0. It's going to be this distance here, i.e. it's the height of the tower. After how many seconds does it hit the ground? We're going to be doing like we did before with the diver, 12.25 plus 14.7 t minus 4.9 t squared equals 0, because remember It's the height above the ground, so I'm interested in when it's equal to 0. We get 3.679. And we're probably going to get another negative, minus 0.679. So reject. And round this one to 3 sig figs, 3.68 seconds. Okay. Part C, we have to complete the square again. Factorize out that minus 4.9. Then we have to see how many 4.9s go into 14.7. Actually, it's 3. And that's going to become minus 3t. Minus 1.5 squared, which is 2.25. Okay, it just gets a bit more like just technical, I guess, with modeling quadratics, but it is the same kind of thing that we've been doing. And then times those two together. So it's going to be double negative 4.9 times 2.25, 11.025. And I'm just going to go straight to it and add on the 12.25. 23.275. Just going to write it in the form that they've written it again, just like with the diver. A equals 23.275. B equals 4.9. And C equals 1.5. Brilliant. Find the maximum height. Again, it's very similar. Max height is going to equal 23.275 when t equals 1.5 seconds, similar to that starting bit of the question. Okay, nice one. Very similar question. So hopefully you tried that one yourself and had a bit more, went a bit better than the first one if you were unsure with that one. Okay, one more to try. Lynn's selling cushions. She sells 80 at the cost of £15 each. Hopes to sell more. Her advisor suggests you can expect to sell 10 more cushions for every £1 that she lowers the price. This is going to be a like maximizing profit question. the number of cushions can be modeled by this equation here, where P pound is the price of each cushion and H is a constant. Determine the value of H. So the number of cushions sold, well, we're told she's expected to sell 80. So C is 80 when P is equal to 15. So I can substitute those values in. 80 equals 230 minus 15H. And we can rearrange that. We're going to get 15H is equal to 150. So H equals 10. Then we can set up the revenue by multiplying the number of cushions sold by the price per cushion. Okay, it's looking good. And we're being asked, oh, but we know what H is now, so I'm gonna go straight to writing 10p there. And we're being asked to write it in completed square form. So it's going to be, first of all, I need to expand it to minus 10p squared plus 230p. And now let's complete the square. So take out the minus 10. It's going to become p squared minus 23p. And complete the square, p minus, it's going to be 11.5 squared minus, and then I need to square 11.5. 132.25. Which is going to be minus 10 p minus 11.5 squared plus 132.25, which is nearly in the nearly as they've asked for it. Again, we just need to switch it around like so. And I'm just going to say what A is again. Okay, looking good. Using answers to part B or otherwise, show that Lynn can increase revenue by £122.50 through lowering her prices, and state the optimum selling price of a cushion. Okay, so we need to think about this carefully. The maximum profit, or is it profit? I've forgotten, to be honest. Maximum revenue is going to equal 1322.5 when P equals 11.5. And then we can work out the number of cushions sold, because what we're trying to do, we're trying to work out R. So we need to work out the revenue when for the original one, when she sold them for £15, when P equals 15, R was equal to, I can just, to be honest, I can substitute it into this one here. It's going to be 15, I didn't do that before, 15, 230 minus 150. I've just substituted in 10 times 15 into there. So that's going to be 15 times 80, which I think is 100 and, hold on, let's just check. 1,200, isn't it? 15 times 80. Brilliant. And we're nearly there. I can see the answer coming out now. So increase in revenue equals 1322.5 minus 1200, which is £122.50 as required. Okay, so not too bad a topic. Just technical questions involving like these wordy bits. You've got to identify what you're being asked for. This latter question, you've got to be a bit, I think this is the toughest one. But you can see how quadratics could, in theory, be used to model it. I mean, we're just coming up with this model, but there are times when it could be valid. And actually, it turns out that when you dive and throw things, it does approximately. It can be approximately modeled by a parabola. So that's all good. I hope these questions make sense. Do some more practice. Well done.